Metal conduit serves as an equipment grounding conductor, providing a path for fault current to return to the source. This grounding path is crucial for safety, as it helps to trip a circuit breaker or fuse in the event of a fault, preventing electrical shock hazards. The metal conduit system, when properly installed with listed fittings, creates a continuous, low-impedance ground path. This path ensures that metal enclosures and device boxes are effectively grounded. When a fault occurs, such as a live wire coming into contact with the metal enclosure, the fault current flows through the metal conduit back to the service. This high current causes the overcurrent protective device, such as a circuit breaker or fuse, to operate, quickly disconnecting the circuit and minimizing the risk of electrical shock or fire. The effectiveness of metal conduit as a grounding conductor depends on several factors. Firstly, it is essential that the conduit is properly installed and tightened. Loose connections can significantly increase the impedance of the grounding path, reducing its effectiveness. Secondly, the type of fittings used to connect the conduit sections onto the device boxes must be listed for grounding purposes. Listed fittings are designed to maintain a reliable electrical connection between the conduit and the enclosure. Thirdly, the conduit system must be continuous from the device box back to the service equipment. Any breaks in the continuity of the conduit can compromise the grounding path. In addition to the metal conduit, an equipment grounding conductor, often a green or bare copper wire, is sometimes run inside the conduit. This conductor provides an additional grounding path, especially in situations where the conduit may not provide a sufficient grounding path on its own. For example, in areas with corrosive environments or where the conduit may be subject to mechanical damage, an equipment grounding conductor is recommended. The National Electrical Code, or NEC, provides specific requirements for grounding and bonding electrical systems. Article 250.4 of the NEC addresses general requirements for grounding and bonding, emphasizing the need for electrical systems to be grounded in a manner that limits the voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines, and stabilizes voltage to earth during normal operation. Article 250.118 of the NEC lists types of equipment grounding conductors, including metal conduit. Specifically, it mentions rigid metal conduit, intermediate metal conduit, and electrical metallic tubing as acceptable equipment grounding conductors. However, it also emphasizes that the installation must comply with all applicable requirements of Article 250. Article 250.130 of the NEC covers equipment grounding conductor connections. It specifies how equipment grounding conductors must be connected to the grounding electrode system at the service. It also addresses grounding requirements for separately derived systems such as generators or transformers. Article 300.3 of the NEC addresses the requirements for conductors in the same raceway or cable. It specifies that all conductors of a circuit, including the equipment grounding conductor, must be installed in the same raceway or cable. This requirement helps to minimize impedance and ensure effective grounding. Article 314 of the NEC covers outlet boxes, conduit bodies, and handhole enclosures. It specifies the requirements for grounding these enclosures, including the use of bonding jumpers to ensure electrical continuity. In addition to the NEC requirements, local codes and regulations may also apply. It is important to consult with a qualified electrician or electrical inspector to ensure that all grounding requirements are met. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. Table 250.122 of the NEC provides the minimum size of equipment grounding conductors for various overcurrent device ratings. For example, if the overcurrent device is rated at 20 amps, the minimum size of the equipment grounding conductor is 12 American wire gauge copper or 10 American wire gauge aluminum. If the overcurrent device is rated at 60 amps, the minimum size of the equipment grounding conductor is 10 American wire gauge copper or 8 American wire gauge aluminum. If the overcurrent device is rated at 100 amps, the minimum size of the equipment grounding conductor is 8 American wire gauge copper or 6 American wire gauge aluminum. The equipment grounding conductor must be connected to the grounding electrode system at the service. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The connection to the grounding electrode system must be made with the grounding electrode conductor. The size of the grounding electrode conductor is determined by Table 250.66 of the NEC. The grounding electrode conductor must be securely connected to the grounding electrode into the service equipment. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This low impedance path ensures that the overcurrent protective device will operate quickly in the event of a fault. A high impedance grounding path can prevent the overcurrent protective device from operating, which can lead to electrical shock or fire hazards. Grounding is a critical aspect of electrical safety. Proper grounding helps to protect people from electrical shock and to prevent damage to equipment. It is essential to follow all applicable codes and regulations when grounding electrical systems. Regular inspection and testing of grounding systems are also important to ensure their continued effectiveness. Visual inspection of the conduit and fittings can help to identify any loose connections or signs of corrosion. Electrical testing, such as continuity testing and impedance testing, can verify the integrity of the grounding path. In addition to grounding, bonding is also an important aspect of electrical safety. Bonding is the process of connecting all metal parts of an electrical system together to create a common electrical potential. Bonding helps to minimize voltage differences between metal parts, which can reduce the risk of electrical shock. Article 250.92 of the NEC covers bonding of metal enclosures. It specifies that metal enclosures must be bonded together to form a continuous electrical path. This bonding can be achieved by using bonding jumpers, bonding screws, or other listed bonding methods. When working with electrical systems, it is important to always follow safe work practices. Firstly, always de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Thirdly, follow all applicable codes and regulations. Fourthly, if you are not qualified to work on electrical systems, hire a qualified electrician. Metal conduit is a robust and reliable grounding method when properly installed and maintained. It offers a durable and long-lasting grounding path, making it a preferred choice in many electrical installations. However, it is crucial to ensure that all connections are tight, fittings are listed, and the system is continuous to maintain its effectiveness as an equipment grounding conductor. Incorporating an equipment grounding conductor within the conduit provides an extra layer of protection, especially in environments where the conduit may be susceptible to damage or corrosion. This combination ensures a safer and more reliable electrical system, minimizing the risk of electrical hazards. Therefore, while metal conduit itself can serve as an equipment grounding conductor, adherence to best practices, code requirements, and the consideration of environmental factors are essential for optimal safety and performance. Regular inspections and testing are crucial to verify the integrity of the grounding system and ensure the safety of electrical installations.